Thanks for coming. It's been a long AWE, so appreciate you making it out here on Thursday afternoon. I'm Max. I'm the product manager for all the spatial computing workflows that we do at NVIDIA. And so that both encompasses what we do with Omniverse and getting Omniverse to spatial devices, but then our entire XR streaming stack. And we've been working on XR streaming for a number of years, starting mostly with simple AR experiences for phones and tablets. And those are kind of the golden days. We just had to send a single eye with color and alpha to a device at a decent amount of resolution. We quickly jumped to doing streaming VR. So we got to ditch the alpha channel, just send 2 eyes of color to a device. But then last year with the Apple Vision Pro, we got sort of our first taste of a completely untethered device at a really high resolution that's mixed reality focused. And so at that point, we started talking about 2 eyes with color, with alpha. And then at that resolution, we found a really strong need for a re-architecture of our reprojection system. And to do that, we started to send depth to the device. And once you include depth at 4K per eye with color and alpha, we had to send about 27 million pixels down to the device over the network. And this was a pretty monumental challenge for us to solve. And that's what we spent the past year doing, is bringing something like Omniverse to the Vision Pro. And what's really exciting about this is we get the benefits of the incredible computing power that are on that device, and we get to combine them with this off-device computing power of our GPUs and of Omniverse. And we call this split compute or hybrid compute. I've actually been really stoked to see a number of talks here at AWE this year talking about this concept, and I'm really excited to sort of see it catching on. The idea here is that we all know that there's some limitations with devices, head-worn devices like this, especially with weight and battery life. And we want a future where these devices continue to get smaller, more lightweight, have longer battery life. But we don't want the computing power of these devices to sacrifice the fidelity or the quality of the experiences that we put on there. So if we can start to build this bridge of applications where the computing is shared between on-device and off-device, we think these devices can continue to get much smaller, much more lighter weight, but we can continue to do really awesome workloads like we do in the automotive space, the industrial space, digital twins, and especially AI workloads. So the architecture for this is pretty simple. You build your Omniverse application using our Omniverse SDK. Omniverse is where you're going to aggregate all of your OpenUSD data from your various authoring tools. We have a bunch of really cool USD NIMs for content generation as well that we love to bring into this fold. And then that content goes either on your local workstation and over your local network, or up to GDN, which is our graphics delivery network. And then our Cloud XR protocol is the stack that then streams that down into the Vision Pro. And on the Vision Pro, we have what we call our Cloud XR framework. And so Swift frameworks are familiar to most Apple developers. And so that's where you can integrate that Cloud XR stream. And really for developers, it's just any other 3D entity in your Vision OS application. So you can continue to combine other Swift UIs. You can even have local USD assets right alongside that streamed render from Omniverse. So we thought this was pretty cool, and we put it out into the world at CES. And we have some amazing partners who've been building some really incredible experiences. Our friends at Katana with Nissan are building digital twins of all of their vehicles, taking these to trade shows, even thinking about putting it in sales rooms across the globe. When we showed this to Nissan, one of the classic issues of doing a car configurator, especially for a device with sort of restrained compute, is you lose all the detail in the interior, because the interior of a car is full of different textures, text, tons of minute details. But because we could keep the original CAD data of everything that's in that interior car and stream it, when we combine that with the quality of a display like a Vision Pro, everyone's heads were just completely blown away. Our friends at SoftServe, a large integrator that we partner with a lot for our Omniverse use cases, they also have some great automotive use cases. And then our friends over at InnoActive have been working with groups like Syntagon, which it's funny, a car has lots of details, but in fact there's many digital twins out there that have incredibly complex systems and CAD architectures that lead to a need for using off-device compute to be able to visualize what they're trying to do. And so Syntagon will build these massive scientific sort of facilities with all this equipment. It's too big for them to take to trade shows or take on site to a customer. They don't want to take a sort of decimated, reduced version of that asset to a customer when they're trying to plan these research labs, but now they can just stream it and keep all that data intact. We also have our friends at PTC. They make PTC Onshape for Vision Pro. And again, this has been a great case study where they also have native USD rendering inside that Onshape app that renders the USD locally on the device. But then they're also integrating Omniverse such that a customer could just switch to the Omniverse version and they get that super high quality path trace version of that CAD asset. And then at groups like Pegatron, who are putting together these massive data centers and these system racks with hundreds of thousands of individual components in them. They're using this for training. So somebody who's having to assemble these data racks and they've never actually put these racks together before, they sit there with a Vision Pro on, and to their left is the digital version of that rack, and it just walks them through the process of everything that they have to assemble. And then one thing we're announcing this week is we've now also ported this spatial streaming stack to iPad. And so for folks who keep up with Swift and RealityKit development, Apple's done a great job of making their sort of spatial SDKs compatible between iPad and Vision Pro. And so now you can build a Vision Pro application with our SDK and also deploy that application to iPad as well. We like iPad a lot. It's a much larger market than the Vision Pro. It's a great device to use for shared workflows where you might need to have a few people looking at a digital twin at the same time. The other thing we've been up to for the past 6 months, and that's new sort of as of this week, is moving our entire back-end architecture to OpenXR. So we love OpenXR at NVIDIA. We think it's a really critical part of the XR ecosystem. And the goal here is to move CloudXR to a system that can more natively integrate with any OpenXR device that's OpenXR compliant. Now, this brings us a lot of interesting opportunities, the most important of which is the ability to bring non-Omniverse applications into this spatial streaming workflow. And so this past week, I had my engineer bring up something that I knew would be impossible to run natively on the Vision Pro. Let's see if this video is even going to load. Let's try one more time. I guess it's impossible to see. Hey, AV, is that video playing back by chance? I'll just describe it. So this would be a video of Unreal running on a desktop PC. We have their procedural world sample, which if you've seen it before, it's just this incredibly detailed sample asset that they have. And we have that also now streaming to the Vision Pro. And again, it's one of those things where you see it paired with the quality of the display in a device like this, and it kind of takes this level of fidelity up to a really exciting point. So we'll have this in early access a little bit later this summer. Unreal's not the only party that's invited to this. It's going to be any application that's OpenXR compliant. So we're really excited about that.
Is that engine version agnostic, or is it Unreal 5 specific?
It's any OpenXR application. Yeah. And then there's some other fun stuff that we're doing in the VR space that's not necessarily automotive. One thing we talked about earlier this year at CES and GTC was Isaac GR00T. And what's really interesting about spatial devices intersecting with robotics is that they kind of have this data generation bottleneck right now, which is if you want to train a robot to do something manually today, it takes one human sort of piloting that robot and trying to teach it a task. And so that means we can only train robots by putting in actual person hours to training those robots, and that's going to really slow down the development of all these things. And so why not train those robots digitally in a digital twin of that robot? And so Isaac GR00T allows a Vision Pro user to essentially connect to a one-to-one digital twin of a humanoid robot, operate a task, and then we feed that into a system that we call GR00T Dreams. And that generates synthetic versions and alternate versions of that training task that they just did. So for example, you train it to pick up a glass of water, and then we can use generative AI to generate all the variations of what could be in that cup, the size of the cup, how empty the cup is the cup metal or plastic or clear, and really start to turbocharge the data generation problem of these systems. And we think this is going to be crucial not only to developing humanoid robotics, but anything else that's going to have a sensor or a camera on it. You know, today, I think one thing that folks aren't totally aware of is just sort of how much manual tagging goes into training these foundational models. And just like folks tag images and text for some of the more traditional AI models, we're going to have the same thing for robotics. And so kickstarting and really trying to ramp up this training data collection for robotics is going to start to quickly change this ecosystem and get it out to market a lot sooner. And then the last thing I'll highlight, this is to sort of flip things kind of the other way around, is that we also use Omniverse to simulate cameras and sensors, things like LiDAR, and for headset makers themselves, let's say you're designing a new device and you want to plan out where your cameras, where your sensors are. We have a new service that we call Sensor RTX that it's purpose-built for you to be able to simulate what those sensors and cameras will do inside a digital twin. And so if you're iterating on the design of your head-worn device, you want to see, hey, let me try to move this camera a couple millimeters this way, a couple millimeters that way. You can do that inside your digital twin and then feed that into your perception stack. And again, kind of start to generate that training data that you need to be able to make those perception stacks not only faster and more accurate, but to also do that design iteration loop without building physical hardware. Because again, that's sort of the critical part of all these digital twins, is being able to do all of these things digitally without building the physical version of it. So you can learn all those mistakes, try out different ideas that you may not want to try out when you build the digital or the physical version as well. So that's a quick recap of what we've been up to on the spatial computing team at NVIDIA. So here's a QR code. This can get you started really quickly. We have tons of great samples and workflow guides that can show you not only how to get started with Omniverse, but also show you how to get started with our spatial streaming workflows. I have a few minutes for questions. Thanks for coming. Really appreciate it. Joe.
Yeah, with the OpenUSD, has there been any experimentation with open collaboration with the Apple Vision Pro that have multiple users?
Yeah, there have. So the way I'll hop back to that architecture slide. One more. There we go. So we're not only just sending pixels and poses back and forth between the server and the client, we have a message bus that goes between there as well. And that message bus is where developers can sort of put any type of data that might be purpose-built for their use case. And that's exactly where some of the multi-user workflows are going. And so, for example, we could send one user's position or actions in a scene down to that message bus, and then link that message bus to other Omniverse sessions that are going on. And then a user connected to that on their own device would receive that back from the server. And so you can have both a sort of a server-to-server architecture for that communication, but you could also have a client-to-client setup as well. We haven't looked too deeply into the APIs, like the SharePlay APIs on the Vision Pro. We know that there's some limitations in there around shared anchors, but I think some of that's actually changed this week with WWDC. But we do have some developers looking into it actively. Yeah.
We've done streaming with other solutions that you have two problems that are quite common. One is like just starting it up. It takes a long time for like you to ramp it all up if you have it on the cloud somewhere. Are you able to overcome that so there's not like a delay? And the second one is there's always latency.
Yeah.
In the sense of like if you want to have an actual real interactive experience, it doesn't work very well because there's always this delay.
Yeah. So we have a couple ways that we solve that. The first is with that GDN, that graphics delivery network that I mentioned. That's built on top of our GeForce Now service, which is a global sort of infrastructure of data centers where we've tried to put our highest end GPUs closest to where people are. And so that's the first way I eliminate that latency, is making sure I can get a GPU as physically close to you as I can. Can't put a GPU everywhere, like we know that's still kind of a physical limitation. But that reprojection algorithm that I mentioned is actually suitable for anywhere from 80 to around 120 milliseconds of round-trip latency. And there's a couple reasons for that. One is we send the pixel stream and that message bus stream on different UDP and TCP channels. And so even if there might be some delay in getting pixels to you, we can actually get information that might be tied to an interaction between the server and the client quicker than those pixels. And so that helps that sort of interactivity lag. And then that reprojection algorithm makes it such that if you're in that sweet spot of 80 to 120 milliseconds, most users, unless you're doing a highly active VR experience, that reprojection system that we have is pretty much imperceptible. You see it a lot at the edges. We see reprojection artifacts of like as you sort of move quickly around an object, we can't quite fill in behind it soon enough. But the nice thing is that because the reprojection is happening on device, that experience in the Vision Pro, for example, is running at 90 hertz. And so even if your server is taking a little bit to get frames down to you, we don't upset the comfort of the user in that way. Yep.
So with the GPU deployment usage per job or user, is it a one-to-one ratio? Each job has a GPU. And what are sort of like the long-term plans to scale? Say there's 100,000 users. That doesn't necessarily mean 100,000 GPUs, but like, would you have concurrent workflows per GPU?
Yeah, so right now it is one user per GPU. And so the scaling factor that you gave me is accurate. If you wanted to have 1,000 concurrent users on your service, we need to reserve 1,000 GPUs for those users. We do have systems to split those GPUs depending on the use case. I think the critical thing to remember with a lot of these digital twins, especially say that Syntagon example, is you're still going to be memory bound. So even if we can split up the actual compute of a GPU, a digital twin like that, or even the car on the right, could be anywhere from 40 to 60 gigabytes of video memory. And so you do kind of start to hit the limit of what you could splice a GPU into to be able to load those large scenes. Yeah, so what's really cool is because both the Vision Pro and Omniverse are backed by a USD pipeline, you could in essence have an application that allows a user to choose between a local USD asset that maybe you decimate and compress a little bit to fit in the memory footprint that the Vision Pro supports, and then be able to switch to a higher quality version at any time. And your application really doesn't care. You're just trying to draw a 3D asset, and one's pointing out to a pixel stream and one's pointing to a local asset. I will say that the going back to one question I didn't answer is sort of the loading time issue there, is that can also be tied to your asset size. And so there are just, again, sort of physical limits of getting data from a hard drive into the GPU memory that can sometimes take seconds, but can sometimes take minutes. Those Nissan cars load in around 90 seconds total to get a pixel stream up and running. So things like that are all kind of variable depending on the use case. Yeah? Yeah, Joe?
This might be a bit of a digression, but has there been any utilization of the Apple Vision Pro and something like a whisper interaction as far as like voice communications, as far as to interact with an LLM with the actual Omniverse?
Yeah, so we think what we're showing today is kind of the beginning of this architecture of edge devices communicating with larger GPUs on the back end. Those AI workloads are kind of spinning up as we speak. And so we've seen use cases of connecting the camera feed from the Vision Pro back to things like VLMs and VSS models. We've certainly seen sending audio back, connecting those to chat models. There's on-device speech-to-text, so that message bus system I mentioned, you could do local speech-to-text and then send that text back up to a model. And so we have lots of developers who are able to plug in different NIMs and chatbots into their OpenUSD scenes. So it's kind of one of the upsides of USD is it's a sort of a file format that's easy for an LLM to interact with. And so the tricky part there is the first question I get is, can I do an AI workload and an Omniverse workload on the same GPU? And again, we hit those hard limits again. But the nice thing is that we have scale. When we're up in a data center in a cloud, we have access to that scale to sort of pull in additional resources. Yeah, yeah.
Do you have any? So I mean, as you have Katana and Nissan, are there other companies, enterprise companies, that have seen like high success deploying this type of thing on the Vision Pro today, and what kind of metrics can you cite at this point?
Specifically on the Vision Pro, we have pretty much a majority of the automotive teams taking a look at it. Deploying it in production tends to be sort of throttled by a couple of problems. One is that we have a pretty intense network ask of streaming this many pixels over a network that a lot of corporate networks I don't think are ready for today. We're working on that on our side. For example, I think in probably all three of these that you're seeing, we need about 60 megabits of downlink bandwidth per device. Not bad at home, but I don't know what your all's corp environment is like, but like I can barely get 10 or 20 megabits depending on the day. So there's some hurdles there. There's some other issues around OSHA certification, CE mark in the EU and stuff like that. But the primary proof points that we're seeing are, one is the ability to scale the number of users who can access that compute. These are teams that traditionally had workstations per user in their setups, and that sort of gated how many people could access all their VR experiences that they were using. And so pulling that up into the cloud, we see great scale there. Our friends at BMW are already doing this, where they have kind of a cloud-based, internal cloud-based system for running some of their XR applications. And then the fidelity is, again, sort of the other thing that's really taken a hold. I think when most folks see a really high-quality digital twin at this level in the Vision Pro, going to other devices and going back to other software programs, it's quickly apparent to them that they have to sort of up their game and sort of the amount of fidelity that they're trying to keep in their pipeline all the way to XR. Cool. Awesome. Well, thanks, folks, for coming by. Really appreciate it. Have a great rest of your AWE.